Welcome to practicals under course Computer Aided Engineering, and today we'll learn how to perform experiment number 1. The title of experiment is Structural Linear Analysis using 1D bar elements, and here is the problem statement. Determine the nodal displacements and element stresses by finite element formulation and software tool using the following figure. Okay. Please note down the input data. So we'll move on to the APDL screen. Yeah, so this is how the APDL screen looks like. And initially I will select preferences. So under preferences, I have to select or we have to select structural, as this problem belongs to structural domain. Next, under preprocessor, there are a lot of many options. Under this, first option is element type. So let us add the element. So add, edit, delete. Under add, edit, delete, again add, and under add there is a link element. Okay, and just add it. So see that the link 180 element is added. Okay, and say close. Next option you have to select is material properties. So under material properties, go to the material model, and under material model select structural linear elastic, okay, and isotropic. And here we have to give E value, that is modulus of elasticity, as an input, which is 2 into e raised to 11. So I have converted that GPa into Pascal. Okay, and next the Poisson's ratio is 0.3. Okay, and say OK. Next is exit material model. We have to exit. Next option that we have to select is sections. Under sections, go to the link. Okay, link, and under link say add, and we have to give the section ID as a 1, because when you see the problem statement, there are two cross sections. Okay, there are two steps. First step has area A1 and second has A2. So we have to create the section ID as a 1 and say OK. And under this, let us define this as a square section 1. And under that, under the link area, we have to give value input as a 0.5. Say apply. And again, it will ask for the next material section ID. So I'm giving 2 as an input. Say OK. Again, I will give the name as a square underscore 2. It is second section ID, and the input is 1. Say OK. Next important thing, that is modeling. So under modeling, we have to create few nodes. See, in the problem there are we have to create 4 nodes as the problem physics is. Okay, so under create, say nodes, and again active coordinate system. Select the active coordinate system, give node number 1 as a name, and this XYZ location I am going to select exactly on the origin. So the input selected is 0, 0, 0. Say apply. For the next, we have to give input. See the geometry. Say this point. For this point, we have to give input for this point, which is at 1 meter away from the origin. Again, for second, I will give input as a 1. Say again apply. For the third, I will increase the length as per the diagram. The length is, total length is 2 meters. Okay, up to this step. So again, I will give the input as a 2, length as a 2. I am increasing only x coordinate. Okay, and the last coordinate, that is 4, which is at 4 meters away from the origin. So I am giving it, and at the last we have to say OK. So see that there are 4 nodes that are created. Again, go in the elements, and under elements, we have to select auto numbered. First, we'll check the element attributes and see that the section number selected should be 1, because we are going to create first 2 elements which has the area A1. Say again auto numbered through nodes. Select node number 1. Select node number 2 and click or press middle button. Okay, and the element is created. Okay, again go in the again press or select node number 2, node number 3, and press the middle button. Okay, that's how the first 2 elements are created, which has the area A1. Again go in the element attributes, change the cross section area to section 2. Okay, say okay, and again in under auto numbered through nodes, select again node number 3, node number 4, and say press middle button. That's how the elements are created. Again to see the elements created, go in the plot control, plot control style, plot control style, size and shape. Under this we have to say display of element on, and see that the elements are displayed. Okay, again go in the plot, multiplot. Okay, see that's how the elements are displayed. See the isometric view. Okay, and you will get clear about the elements. Okay, again standard front view I'm going to create. Next important thing is going for the loads. Again for the loads, this end is free but this end is fixed, so I will give the first fixed load. So again define load, apply, structural, again displacement on node, and select this node. Okay, this node, the node which is at the right end. Say okay, and give the all degree of freedom equal to 0 because it is fixed. Okay, and the symbol is shown for the fixed element. And for the point load which is present at this node 2, which is 300 Newton, okay, we have to use the F command. Okay, so go in the prompt, command prompt, say F, just type F, select the node number or put the node number which is 2 in our case, and how the orientation of the force is. So force is in the x direction, so it is Fx. Okay, and put the value of the force which is 300 kilonewton. So again it is 300 into 10 raised to 3. Okay, and say enter. See, the force is created. Okay, that's how the force is created. Again the preprocessor tab is over. Okay, under solution tab, just hit the solve button. Okay, under solve current ls, you have to just hit. Okay, and the solution is done. Okay, next important thing is that we have to see the results. Okay, so under general post processor tab, okay, go to the plot result tab, plot result. Okay, under plot result, see the deform shape. Okay, again under deform shape, select deform plus undeform, say okay. So see that the node number 1 is also had displaced towards the right side. Again node number 2 and node number 3, but node number 4 is exactly at the fixed, exactly at the original position. So you have to take the image of this. Next important is contour plot. Under contour plot, go to the nodal solution, DOF solution, and displacement vector sum. Okay, and say okay. So you will see the colorful image of the displacement, and the red color indicates the maximum displacement area, and the blue color indicates minimum displacement area. Again you have to take the screenshot of this. Next important thing, we have to see the stress plot. Okay, so for that we have to go to the result viewer. Okay, result viewer. Under result viewer, click to the choose a result item. So under this you have to select the stress, and under stress also we have to select the von Mises stresses, and say contour plot, and the next button is plot. Okay, when you do that, okay, you will get the stress plot as well. Okay, see, zero stress is applied at node 1, but maximum stress is exactly at the junction of the two sections. Okay, again you can take the image of this, okay, by image capture option. Okay, close it. Okay, it will return back. Now these were the images. Now I want the numeric data. For that, again go to the list results. Okay, list results, and the nodal solution. Under nodal solution, DOF solution, displacement vector sum, say okay. Okay, so that's how you will see, or you will get the values of displacement of each node. Okay, these are the values. Okay, again you have to take or you have to copy this